In this video, we are going to discuss confidence intervals. Our work on confidence intervals has three objectives. First of all, understand when valid statistical conclusions can be made. We also have a skill based here, calculate an estimated margin of error and the 95% confidence interval. And based on your work for objective 2, write or make a confidence statement. And so here we go. I would suggest that you pause and read through this paragraph because, of course, I don't want to read it to you. One of the things we've discussed is a census. Remember, a census is when you look at every single person in the entire population. So you know exactly what's going on because you've looked at everybody. We've also discussed that if you want to do a census of the United States with all our 320 million people, you're going to spend a couple $1 billion on it. So most of the time, a census just is not possible. That's why we do samples. The main idea behind statistics is this. We want to look at a sample, a good sample, a representative sample. And then we're going to crunch numbers on the sample to create a statistic. Based on that, we want to make predictions about the overall population, the overall big group. So for example, we will look at the people in Newtown and generalize it to talk about all the people in North Dakota. Or we could look at the people in Texas and generalize it to say everybody in the United States. This process of confidence intervals that we're focusing on today is how we will do that. How do we use a sample to make predictions about the overall group? How do we make conclusions about the overall group? Well, along the way, there are a couple of things that we need to discuss. We are going to discuss margin of error, and we are going to discuss a confidence interval. If you've ever paid attention to the news, one of the things that they're big fans of putting on are, what are President Obama's favorability ratings? Well, they can say 42% of people approve of the job President Obama is doing. Or they can say 54% approve of the job that President Obama is doing, or 35%, or whatever. But they'll look at it and say, some percentage of people approve of President Obama's job performance. But then when you look after that, they always say margin of error 3%. Or it'll say plus or minus 3%. Why do they always put that thing in there? Why is it that when they talk about the president's job performance, they always say this thing of a margin of error, whoa, didn't mean to move that, a margin of error plus or minus 3%. What is that? Where does it come from? That's our focus today. What is that thing and where does it come from? How do we make it ourselves? Part of this thing that we're going to look at is we know that if we take a sample, we don't include everybody. We don't have all 320 million people. So we can't be 100% bet your life certain on it. How confident do you want to be? Do you want to be 20% confident that you're correct? Do you want to be 80% confident? You want to be 90% confident? The only way you can get to 100% confident is to do a census. Well, we can actually look at a lot of different percentages and say, I am 50% confident, I'm 80%, I'm 90, I'm 99%. It's possible to make 99% confidence intervals, or 50% confidence intervals, or 70, whatever percent you want, it's possible to make them. It's also possible to do confidence intervals based on averages. Like, how many pets does the average person have? Or how many cars, on average, do people own? It's possible to do confidence intervals on averages. It's possible to do it with whatever percent you want. But in order to do those things, we need some stuff from our Unit 7. Specifically, we need z-scores and typically the normal distribution. We've not done a single thing with those at all this year. We will in Unit 7. And so we can come back to this idea later in the year, and we will look at it and say, let's see these things in another context. Since we don't have the tools for z-scores and the normal distribution, we're going to do simpler confidence intervals for now. For us, right now, we are always going to be 95% confident. It's basically, since we're using the simpler method, it's taking advantage of shortcuts that we're not going to discuss why those shortcuts work. But we're going to use 95%. Also, we will only do confidence intervals on percentages, like what percent of people know how to dribble a basketball? What percent of people have been in a car wreck? Not the average number of car wrecks a person is in, not the average number of pets. We will do only percentages for now, and when we come back in Unit 7, we'll do averages and we'll do other percents then once we've got the better tools, okay? Definitely pause the video, write all this stuff down, and you can see right up at the top how important this is for you to know. Several things before we move on that I would like to notice. Of course, I'm sure you've noticed that N is the sample size. So did you ask 20 people? Did you ask 50? Did you ask 1,000? How many people did you ask? Or how many people are included in your sample? We will need to know the N to calculate the margin of error, which I will abbreviate ME. We can see that the margin of error, just like we said that 3%, is plus or minus 1 over the square root of the sample size. And the last piece worth noting, this symbol right here is the statistic, so it's our percent that we're going to have based off of. This is read P hat. The little roof-looking thing, it's called a caret. I know you don't care about the word. I don't expect you to know that it's called a caret. But when you read it, you would say P hat plus or minus the margin of error. And let me erase this stuff now. All right, here is one of our two examples. A random sample of 125 union members was conducted to see whether or not the union members would support a strike. 64 said they would support a strike unless safety conditions were improved. All right, so we're going to run through a lot of the things that we've already done before. What is the population of interest? What is the overall group of everybody that we're looking at? Okay, the population are the union members. But please notice, this is not saying that it's a 125 union members, because we're told a random sample of 125. They're sampling 125 people to make a conclusion about the overall group of everybody. And they didn't tell us how many union members there are. There could be 20,000 union members for all we know. There could be 200, there could be 500. We don't know how many there are. What is the parameter of interest? It's a little bit tricky. The parameter is the variable we're looking at. Okay, it's definitely based on whether or not they want to strike, but it's not the number of people who want to strike. It's the percentage of people, the percentage of the union workers who want to strike. And I ran out of room, so I got to put all this stuff here. And I know it's a bit goofy, but please go with it. What percentage of union workers who want to strike? That's our parameter of interest. Once again, I want to emphasize, with what we're doing right now, everything we're doing is a percentage. So when you're working on your homework, when it asks you to identify the parameter, for now, it's always a percentage. When we get to Unit 7, you will have to determine if we're looking for a number or an average instead of a percentage. Continuing, what's the sample? It's kind of nice. We outlined it already in red. Those 125, I'm writing the word random. Got it in my head. The 125 union members who they asked, do you want to strike? That's the sample. At this stage, we have to conduct, or rather calculate our statistic. This is why I emphasized so heavily that our parameter was a percentage, because it tells us our statistic is a percentage. What percent of union members wanted to strike? Well, it wasn't 64%. You're absolutely correct that we had 64 people say they want to strike, but it was 64 out of 125, so you're absolutely correct, Keenan. We'll take 64 out of 125, and we need to divide that out to turn it into a percentage. Okay, so we got 0.512, which is 51.2%. Our next thing we needed to calculate is the margin of error. This is why I had you write down the formula. The margin of error in this specific context is 1 over the square root of n. What's n? Sample size, which was 125. So we need to type in 1 divided by the square root of 125 into our calculators and see what we get. And Keenan told us we got 0.0984. Oh, I have them backwards. 894, not 984. 0.0894, which is 8.9%, rounding to the nearest tenth of a percent. Okay, continuing further, we'll move on to part F. We need a 95% confidence interval. The confidence interval is the statistic plus or minus the margin of error. So our statistic in part D, p hat, is 51.2%. We will have to add 8.9%. We will have to subtract 8.9%. What do those numbers give us? What's 51.2 subtract 8.9? We've got 42.3. And we have to do the adding part. 51.2 plus 8.9 is 60.1%. This stuff that I have written in the black is our confidence interval. Everything we're focusing on today is how do we create that? How do we interpret that? What does it mean? What does it mean is the last thing we'll do here in part G. write a confidence statement. And I'll scroll down a little bit. Now that we've got that, we can write up the confidence statement. What percent did we use? 95%. For now, we will always use 95%. We are 95% confident that the percentage of union workers who want to strike is somewhere between 42.3% and 60.1%. I know it looks weird. I know you're looking at it and saying, why would we do so much writing? Remember, our goal here, we are trying to make a conclusion about the overall population. And we've looked at a sample of 125 people. We know sometimes, because of probability, weird things happen. We know that we could pick a random sample and once in a while just get something that's really freaky, weird, and wrong. Dumb luck happens, we know that. But it doesn't happen all the time. Based on this math, and again, there are shortcuts that have come into showing why this works, but we are 95% confident, which means we have a 95% probability that the real percentage of the entire population, the real percentage for everybody, if we did a census, we think that there's a 95% chance that the real population percentage lies in between these two percents. The 95% came from a shortcut. Basically, without spending a lot more time developing the normal distribution, I can't really go through and explain where the 95% came from, Keenan. Just trust the fact that this 95% came from some more advanced math that we will develop later on in the year. We need the normal distribution, we need z-scores. Basically, we need a couple of days of background to answer that question of where did the 95% come from. We will get there, we will do it, we just won't do it yet. We're focusing on this stuff right now. Okay, let's look at another example of this, and then we'll finish the video. A survey was done to determine the texting habits of NTHS students. A simple random sample of 270 students was conducted and asked several questions related to texting and cell phone use. Of particular interest to the researchers was the proportion. Proportion is another word for percentage. Proportion of students who text while in class. Of those surveyed, 178 said they text during class at least 10 times per week. Identify each of the following as specifically as possible. What is the population of interest? You got it, Joe? NTHS students is our population of interest. That's who we're looking at. What is the parameter of interest? Remember, when we are creating confidence intervals for now, what are they all based off of? The percentage Since we were asked to identify each of these as specifically as possible, you'll notice we're writing down basically word for word the stuff that we're seeing in the problem. We know it's a percentage. You can also use the word proportion if you want to use that directly from the homework. What percentage of Newtown High School, or NTHS, I forgot the word students. How did I forget the word students? What percentage of NTHS students text in class 10 plus times per week? Progressing to question C. What is the sample? Should be fairly easy to check. It really says right here. An SRS, a simple random sample of 270 students. Okay, we've got that. Now we'll move on. Question D. What is the statistic? Our statistic, you should recall, is the percentage. So what percent of students said they text a lot? $178 out of. So we've got the fraction. Let's now get the percent. 178 divided by 270 equals 0.659, which is 65.9%. Now we need to calculate the margin of error. Remember, the margin of error is 1 over the square root of the sample size. And since our sample size was 270, our margin of error is 1 over the square root of 270. Let's put that into our calculators and see what we get. 0.0608, which rounds to 6.1%, rounding it to the nearest tenth of a percent. For part F, we need to calculate the confidence interval. That's just combining D and E. We know we have to take 65.9, subtract. So I wanted that to be a different color. 65.9, subtract 6.1, black. That's 59.8. 65.9 plus 6.1, that's 72.0. Taking the statistic, plus or minus the margin of error, gives us our confidence interval. Now we need to write the confidence statement. We are 95% confident that the true percentage of NTHS students who text in class 10 plus times per week. And I want to pause right here so that you can see the structure And I'll underline it so you can see how to build this a little bit better. One yellow here. We are 95% confident that, well, we're creating 95% confidence intervals, so those words won't change each time we write this up. Since we are making predictions about the population, we're talking about the true percentage. Notice this percentage of NTHS students. This is our parameter, the variable of interest. The parameter of interest, we're just writing it down here again. The percentage of NTHS students who text in class 10 plus times per week. All of these things that we're seeing here in the red, we're getting from here. Just rewriting the parameter of interest. All right, we'll come back and continue to finish this now. Okay, so to write it, we are 95% confident that the true percentage of Newtown High School students who text in class 10 plus times per week is between, and now we'll just write up our confidence interval. 59.8%. Had my decimal in the wrong spot there. 59.8% and 72.0%. And our confidence statement in G is done. Of course, for question H, there's no right or wrong. This is just based on your opinion. Based on what you see in class, do you personally feel that this is too high or too low of an estimate for the percentage of teens at your high school who text during class? Sammy said, well, it seems about right. We're looking about 65.9, so basically, I mean, that's almost 66%, which is 2/3. So this is saying about 2/3 of students text in class at least 10 times a week. That seem right? Does it seem high, too low? What do you think? Okay. So taking Keenan's answer, you say that's way too low. Sammy, you said it seems about right. Well, I guess it depends on your experience. I mean, all of you have a different schedule, so you see different things. So no right or wrong answer. You're just saying, here's what I see. And so here we finished it up. We've looked at 2 examples for making confidence intervals. I want to emphasize a couple things. The most important part of these, the most important thing creating step F and step G are the most important parts of this. Of course, you will not be able to create step F. You won't be able to create the confidence interval if you don't get the statistic correct, if you don't do all the margin of error correct. But the most important things we're looking at, you have to be able to create the confidence interval, and then you have to tell us in G what it means. This is the main reason why we do statistics. Crunch some numbers, and then make a conclusion about the overall population. This step right here, F and G, this is entirely what statistics is about. It's the main idea behind what we're doing. Take a sample, and then based on your sample, you will crunch numbers to make conclusions or inferences about the overall population. That's what statistics does for us.